Okay, so for the first question, we have an exterior angle. We want to find the measure of the exterior angle. There's a theorem that states that the sum of the two non-adjacent interior angles is equal to the exterior. So I'm going to set it up as 2x plus 6 plus 36. That's my two non-adjacents, that one and that one, equals 4x minus 18. Combine like terms, so I've got 2x plus 42 equals 4x minus 18. I'm going to subtract 4 on both sides. You could have subtracted 2 as well. So I get a negative 2x plus 42 equals negative 18. Subtract 42. I like to draw that line down the middle, and I haven't done it yet. Then you get negative 2x equals, sorry, a little glitch in technology, negative 60 divided by negative 2. So x equals 30. But the question didn't ask for what x was, it asked for the measure of the exterior angle. So I have to make sure I plug that back in. So 4x minus 18, do 4 times 30 minus 18. It's 120 minus 18, and your answer is 102 degrees. For the next one, we have two acute angles, and we're in a right triangle. So if I think about this, if this is the 90 degrees, if I take away that 90 degrees, there are two other angles. They have to add to 180. So those two other angles have to add to 90 as well. Because 3x plus 15x plus 90 would all equal 180. So I actually can just set those up to be 90. I don't have to do that 180 part. So 18x equals 90, divide by 18, x equals 5 was my answer. This one did ask again for the measure of the acute angle, so I'm going to plug that back in. So 3 times 5 is 15 for one of my angles, and 15 times 5 is 75. So really, I probably shouldn't have circled the x equals 5. I'll erase that part. That's technically not the answer, though it is an important step. For number 3 and 4, we really need to classify by sides and at angles. So one thing to remember, when we're classifying by sides, that's classifying as a scalene, equilateral, isosceles, and by the measure of its angles, that's classifying by acute, right, obtuse, and equiangular. So you guys can look up what each of those things means. But for this first one, we got 5, 12, and 13. None of those sides are the same because all the sides are different lengths. Sorry, this should have been scalene. Because none of the sides are different lengths, I know that this is a scalene triangle. But I do notice that they have one right angle right here. Because it has one right angle, no matter what, it is going to be a right triangle. For the second one, I have two angles that are the same. Those two angles I have two side lengths that are the same. So with two side lengths that are the same, I know this is going to be isosceles. That's what isosceles means. And if I think about an isosceles triangle, I also know that I have two angles that are going to be congruent, but that doesn't really do anything. We need to know whether the angles are smaller than 180. Well, there's no right triangle, and there are no angles that appear to be larger than 90 degrees. So this has to be an acute triangle as well. So that's my answer for 4, and this is my answer for 3. So when we're working with number 5 through 12, we're looking at the order of how we're writing statements. So corresponding parts have to go in a certain order. So for y is the third letter in the second part of my congruent statement. R is the third letter in the first part. So angle Y and angle R are going to be the same. Angle X is the second letter. Angle Q is the first. Remembering to make sure you keep those angle symbols. We need the angle symbols. Angle P, angle W, and then I don't see another angle one, so I'm switching to side length. So it says XY, so those are the middle two. I have to start with the one that goes with X first. So I'm going to start with Q because Q and X are the same. So QR, RS are the last two, so I go with YZ, making sure I have that segment symbol written above. PS are the first and last letter, so WZ in my second statement, and YXWZ. So I'm starting with the third, YXWZ, and then I'm moving to the left. So I'm going to start with R, and I'm going to move to Q, P, and then S. And so this one isn't a segment because it's naming the entire quadrilateral, so I don't have any segment symbols above it. And same thing for number 12. Q, P, R, S, I'm starting with the second letter this time, moving to the left. So I'm going to start with X, W, and then it went to S, R, so the last letter and then the one to the left of it, so Z, Y. So for number 13 and 14, we're thinking about those base angles theorems. And so 13, I've got two congruent sides. So this is an isosceles triangle. That tells me that the base angles opposite those sides are congruent. So that tells me angle D and angle F are congruent. So one of the things that I know is that this triangle has 180 degrees in it, no matter what. I know that this angle E, is 40 degrees. I want to know what the other two angles should add up to. So I'm going to subtract 40 from the 180. I get 140. And I know that that amount, 140 degrees, has to be split into two angles that are both the same. So two angles, D and F, both measure the same. So 140 divided by those two angles gives me 70. So each angle should measure 70 degrees. Angle D should measure 70, angle F should measure 70. But I need to find the values of X and Y. In this case, I don't have any Y's to look at. I just have my expression of X. Well, this is a representation of angle D. And since I know angle D measures 70 degrees, I can set them up as an equality. So then I can add 18 to both sides. You get 11x equals 88. Divide by 11. X equals 8 for your answer. For number 14, we kind of go through that similar idea. This time we've got in the diagram, angle CDE and GHI are congruent. So notice it says they're congruent. That means C and G, because they're both the first letters, are going to be the same. E is the last, and I is the last. And then D and H are going to be the last. This tells me, this tells me which side lengths are going to be the same as well. So CD should be congruent to GH. This is kind of similar to what we did through 5 through 12. So similar process in that. So I know that 12 should be equal to X minus Y. But now I have a statement with an X and a Y in it, and I can't really solve for one and get a number, and I want to be able to get a number. So it looks like I'm going to have to figure out angles first. Well, one thing that I notice here is in triangle CDE, I have two angles given to me and one that's missing. So I can find that missing angle. 180 minus 58 minus 65, and I get 57. I was thinking 58 plus minus 65 is 123. So 180 minus 123 is 57. So angle C is 57. Well, I know that means angle X, which is over here, kind of wrote through it, but angle X would also have to be 57 degrees because C and G are the same. So now I know what X is. So I can fill in my statement. 12 equals 57 minus Y. I'm going to subtract 57. And I get a negative 45 equals a negative Y. Divide by negative 1. So Y equals 45. That is part of my answer. I did want to find X as well, and I did do it, but I should make sure I write it out formally. X equals 57. Looking at the next page, this is where we get into triangle congruency, and we want to learn and remember what things are what are congruent and what are not. So looking at this, we want to decide whether the relation, whether it's side, 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 angle, side, angle, side, angle, side, angle, 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 side, or hypotenuse leg, would be used to prove that the triangles are congruent. Remember that ASS and trying to think of what the other one is off the top of my head really quick. ASS does not prove congruence. So if you ever see that, it is not congruent. Oh, and AAA. Remembered it. So make sure you remember that they do not prove that triangles are congruent. So in number 15, it gives us JA and AN. I'm going to mark those. I'm going to make sure that this is a smaller fine point. JA and AN, that's a statement. And then it gives us that the triangles are congruent. We want to know how. I should mark two lines there because they're a different set of markings. Well, what is here that isn't marked is this line in the middle. And based on my reflexive property, I know that that line is the same. AK is the same as AK. It's the same line, so it can't be a different length. So based on this, I've got three sides. So this is side, side, side is my answer. For 16, I'm given that the triangles are congruent, and I'm missing one piece of information. I need three pieces of information. Well, I have a side, a side. I also have these triangles intersect, sort of. They touch. And so that gives me a piece of vertical angles, and vertical angles are congruent. So because of that, I then have side, angle, side. And I know there are two sides in one angle, but this isn't ASS because the angle is sandwiched between the two sides. So it's going a side and then an angle and then another side. So make sure you think about it that way. Which one is sandwiched between the others? For number 17, I can use that same vertical angle congruence information to get another piece of data here. And yes, I would get in the habit of like writing down that piece of information. It helps you with the proofs later on. So this time I've got angle, angle, side. Or if I want to reverse order, it's side, angle, angle. The angle is not sandwiched between the two sides. Well, there aren't two sides. The side is not sandwiched between the two angles. So it's not angle, side, angle, because that would mean that the side has to be here. But that's not the case. It's on one of the edges. And for number 18, I have that piece of information in the middle with the reflexive property. So again, I have side, side, side. So this gets us into some proofs. So proofs, one thing to remember is you always can write 3 things down. No matter what, you don't know how to do anything. There are always 3 things and they always go in the same locations. So the first is our given statement. Our given statement, BC, is congruent to CD, and C is the midpoint of AE. That is given to us, so our reason has to be given. Next, the other thing that I can write down is my prove statement. And the prove statement always goes in the last box on my statements. So I'm going to write prove. We want to prove that a triangle ABC is congruent to triangle EDC. So looking at this, I'm going to start marking up my points. It's giving me B, C, and CD. That's a given to me. So that's nice already. I've got that information. Then it's telling me C is the midpoint of AE. I have to interpret what that means. I don't know just by that statement right away what it means. I have to figure it out. So by saying that C is the midpoint, it tells me that AC and CE are the same length. So that's going to be something I have to write down. I have to show them that I know what that C is a midpoint means. And I'm going to write that the reason is because it's the definition of midpoint. For the next statement, I am missing one piece of information. So just like 15 through 18, I need another piece of information. And what I'm missing here is vertical angles. That's the only other thing I can figure out just by looking at this. So I'm going to write angle ACB is congruent to angle ECD based on the fact that they are vertical angles. And because the reason has to be like kind of related to that theorem, I want to write vertical angles congruent. I don't just want to write vertical angles because just knowing that they're vertical angles doesn't mean you remember that they're congruent. And then the last one is filling in that reasoning. So now I have enough information to use angle, side angle, side angle, side, 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 all of those triangle congruence theorems. So I can write that this is congruent based on side, angle, side. For the last one, I'm going to start with the same process. I'm always going to write the things that I know to start with. AD is perpendicular to BC, and angle BAD is congruent to angle CAD. That is given to me. And my last statement, being BD, is congruent to CD. I don't know the reason for that yet. So I can mark this up. So AD and BC, that tells me it's going to hit at a right angle. And angle BAD and CAD are congruent. Well, I'm guessing that the middle piece, which is one of the next ones, is AD and AD. And that's going to be based on my reflexive property because that segment is the same. And then I have enough information to prove this because my angles here are congruent. Right angles are congruent. Really, what I would want is another line that says right angles are congruent. But that's okay. So I've got angle, side, angle. That proves that part. And I have one line that's left. So here's the thing. I know that the triangles are congruent now. Because I know the triangles are congruent, I can use something called CPCTC. Corresponding parts of congruent triangles are congruent. And that helps me because it tells me I can take any other sets of corresponding parts, the corresponding parts being the angles or the sides that should be the same, and write them as a congruent statement. So I can write BD is equal to CD because they are corresponding parts. So CPCTC. And that's it for chapter 5. So hopefully this video helped a little bit if you got stuck on anything. And